good day, geometry. We are starting Unit 6 with the Pythagorean Theorem, arguably one of the most famous theorems in mathematics. And you have background on it before. You've talked about it in previous years, which is awesome. But why we care about the Pythagorean Theorem, this entire unit is going to focus on getting information, specifically solving for missing sides of right triangles. And depending on what you know about the triangle, you might use, various methods to find missing sides. This theorem is used primarily when two sides of the triangle are already known. Okay, and like we saw in the video that we watched moments ago, in a right triangle, which is usually going to have that box down in the corner, you've got sides A, B, and C. C is always the hypotenuse, always that longest side. And we know it has to be the longest side because it's opposite the largest angle, right? In a right triangle, your 90-degree angle has to be the largest one. And based on other things we've learned about triangles this year, the longest side is opposite the largest angle. So there's that relationship there. And then the other two sides, called the legs, are labeled A and B. And it does not matter which one is A and which one's B, okay? The only one that really matters is C. And the Pythagorean theorem looks like this: C squared equals A squared plus B squared. I put my C squared first because of what we're going to do in PO40. But so if you put A squared plus B squared equals C squared, it's the same thing, doesn't make a difference. But I put this first just to kind of lead into PO40, which we posted later this week. Okay, and what it's saying is that the sum of the legs squared is going to equal the square of the hypotenuse. Okay, and you see there are a bunch of roots on this page also. That's because it's actually fairly rare for right triangles to work out with whole numbered sides. And the ones that do are called Pythagorean triples because they're extra special. The first and most common Pythagorean triple is 3, 4, 5, and that's the example that we saw in the video. Okay, these are written as ratios because if you've got a triangle with leg lengths of 6 and 8, you know the hypotenuse is going to be what? 10. Okay. If you have a leg length of 36 and a hypotenuse of 39, what would you know the other leg is going to be? 15. You can see the scale factor from 5, 12, 13 to 36 and 39 multiplied by 3. That means that this would have to be 15. Keep your eye out for Pythagorean triples when taking timed tests, such as the ACT or any placement tests that are timed tests. Because what they're looking for, like the ACT, I don't know if you have any siblings that have taken it before, but it's 60 questions in 60 minutes, and it's timed. Okay, are you meant to answer all 60 questions?
Yes.
Not really. Okay, those that do, they not only know what to do, but they know the most efficient way to do it. So if on an ACT, you've got triangle lengths or side lengths, we'll just use the example 39 and 36, and you're asked to solve for side B, you could do the work. Plug those values into the Pythagorean theorem, move the equation around, solve for B, and you're going to get 15 as an answer. That's probably going to take you, a minute, minute and a half to do, maybe even 2 of them. But someone who recognizes, oh, Pythagorean triple, 15, got it, I'm on, right? 10 seconds. So keep your eye out for these when you're taking those timed tests, because they not only want to know, can you do it, but are you efficient at it? Do you recognize these sorts of things? Okay? Questions so far? Great. Okay. So the part that we're going to talk about that is new to you is simplifying a square root, because like I said, it's quite common for side lengths to be in root form. And so this is something we'll cover later on this year in algebra, PO60, but hopefully you can get the gist of it now. And I told the other group that on a test, I will require your answer to be in root form, but if you go the extra step and simplify it, I'll give you an extra credit point. So it's worth listening to now because then you know how to do it, and you'll be rewarded for it on our upcoming test if you do put your roots in simplest form. So take the root of 18. not a perfect square, right? So we know that if we put this into a calculator, it's going to be like 4.2, and the decimals will go on and on and on. Okay, so it's an irrational number. So what we do is we look for a pair of factors of 18, one of those factors being a perfect square. So our options are root 6 and root 3, and root 9 and root 2. You may not have known this, but if you take a factor pair of a root as roots, you're going to equal the original value. So just like 6 times 3 is 18, root 6 times root 3 will equal root 18. Root 9 times root 2 will equal root 18. Okay? So those are the two factor pairs of root 18. Which one of those has a perfect square? Sebastian? 9. So we don't want to use that. We want to rewrite the value root of 18 as root 9 times root 2. And the reason why we want that perfect square is because we can simplify that. What is the root of 9? 3. So the simplified value of this root would be 3 times root 2, or just 3 root 2. Even though we can't simplify the root 2, we can only simplify one of them. That's still considered simplest form. Okay? If you ever can simplify both of them, then that means you have a perfect square to begin with. Okay? The only time you'll ever be able to square or to simplify both roots, say you're starting with something like root 36, where your perfect square factors are root 4 and root 9. If you can simplify both of them, which you can here to be 2 times 3, which is 6, that means you had a perfect square to start with, because the root of 36 is 6. Okay? So you'll only be able to simplify one of those factors, and that's what you are looking for. The next one, root 40. What's a factor pair of 40 that contains a perfect square? Factor pair of 40 that contains a perfect square. Any more? Julia? Yes, the root of 4 times the root of 10. Sorry, Sebastian, that's nothing personal. Just trying to get other people involved. Okay? 5 and 8 is another factor pair, but 5 and 8, neither of them are perfect squares. 2 and 20, same kind of deal. Okay, 4 and 10 is what we want. And what are we doing with this? Why do we want that perfect square? What would this simplify down to be? Sebastian. Oh, now you don't want to?
No,
oh.
It'd be 40 or no, 40, whatever it's called, rooted or square root.
Root 40?
Root of 40.
Well, that's what we start with. If we want to simplify it, we get this perfect square factor because 2 root 10. Yep. That root 4 is a perfect square. It becomes a 2. And then the root 10, which we can't simplify, just tags along. 2 times root 10. How about root 175? What is the perfect square factor combination for root 175? Alex? Root 25 times the root of 7. So I've mentioned before, going through the math packets, particularly in the pattern block pages, knowing your perfect squares is going to be something that will help you. This is an example. Knowing what numbers are you even considering to go into 175, and then what is that? Root of 25 is 5, so 5 root 7. How about root 600? Root 600, Elise.
Root of 4. No. Wait. No,
4 does go into 600.
Yeah. Root of 4 and root of 150.
Okay. Anybody have, what were you going to say, Sebastian?
Root of 24 and root of 25. What's it at?
Anybody else have another option?
Root of 6 and root of 100.
Okay. So 600 is an interesting number in that it has multiple factor pairs that have perfect squares in them. Okay. And let me take it back to something like the fraction 12/40. If I ask you to simplify the fraction 12/40, could you divide each number by 2 as an intermediate step? Yes. Would it be in simplest form if you divided by 2? No, because you can divide by 2 again, right? So what number would you want to divide by to make it the most efficient process to simplify the fraction?
The largest number.
The greatest common factor, which is what for 12 and 40? 4, right? You could divide by 2, but then you have to divide by 2 again, versus dividing by 4 once, and you're directly there. This is the same kind of thing, to where if I start with 4 or 25, yes, the root of 4 simplifies to be 2, but what does the root of 150 have? It's got a perfect square factor, right? 25 and 6. Which means that the 25 becomes a 5, and my final answer here is 2 times 5, which is 10, and that root 6 tags along. I had a second step there because I used 4. If I use 25 and 24, sure, 25, that becomes a 5, but what does 24 have? 4 and 6. Which that 4, giving me a 2, my final answer is once again 10 root 6, right? 5 times 2, and then the root 6, but it took me an extra step to get there. Whereas 106, donezo. Okay? So we've related a lot of things to fractions lately, but similar to fractions, when you're simplifying a square root, what do you want to look for to make the process most efficient and to make sure you get down to that simplest form right away? The largest perfect square. Can you start with 4? Yes, if you remember to simplify the root of 150. Can you start with 25? Yes, if you remember to simplify root 24. Just like if we divided by 2 up top here and got 6/20 and thought we were done, well, it turns out we aren't. We can go further. Same idea here. Okay? All right. So for the second time today, you've been taught something that normally takes an entire class period, maybe 2, in a very short amount of time. Right? So I don't expect you to have this mastered, which is why if you get an answer on a test of root 40, you can leave it as root 40 and be good. You'll get it correct. If you take the extra step to simplify it, you'll get an extra credit point. So I'm not requiring you to know this, but it will benefit you. Did I make a mistake?
No.
Oh, good. Whenever there's so many hands up in the air, I was thinking I made a mistake. Yes, Audrey, go ahead.
Why do you divide 24
Because it's not considered simplest form. Because there's no perfect square factor of 10. The factors of 10 are 2 and 5. Neither of those are perfect squares. Okay? Just like when I get this fraction into simplest form, which is 3/10, why don't I go any further? Because there are no more common factors. Yes. Yes, only one of them will be a perfect square. Julia. No, if you attempt the simplification and don't do it correctly, as long as you have the original value, then you're fine. So going for it can't hurt you. Linnea.
Well, the test will be like every single one is an extra credit point, or like out of a whole.
Every time that you have the opportunity to simplify, if you do it, it'll be an extra credit point. So I have to make sure, I want to go through the test to make sure there aren't like 10 of them that you could potentially simplify. I'll make it like, 3 or 4. But yeah, and we will cover this in algebra at some point, but it's too much fun to wait until PO61, isn't it? I mean, this is big kid math right here. Okay, questions on this? Okay, so getting to the main event, which is the Pythagorean Theorem itself. Judging by all the writing that's been going on, it kind of looks like you've already started to tackle this. It says solve for the variable, write your answer in simplest root form. I'm not going to require the simplest, I just need the root form. So this first one, 4, 6, and n. Tell me how we're going to set this up in the Pythagorean theorem. What are the legs? What's the hypotenuse? How's it going to look? Go ahead.
6 squared plus 4 squared equals n squared.
Good. Some of you may have 4 squared plus 6 squared equals n squared. That's okay. It doesn't matter because either way you have the a and b arranged, you're squaring them first and then adding them together. And whether you get 36 plus 16 or 16 plus 36, either way, you end up with 52. Okay? So 52 equals n squared. To get n by itself, we're going to root both sides, like we saw in the video and talked about briefly. Taking the root of something cancels out that power. A square root undoes squaring something, just as a cube root would undo cubing something, right? So that's gone. And we're left with the root of 52 equals n. On the test, that would be an acceptable answer. For an extra credit point, what would you now do? 2 excited people ready to share. I don't want to hurt your feelings. So, Sebastian.
You would find the largest perfect square.
Which is what?
6.
Nope.
I mean 4.
Yep. Okay.
We got the wrong one.
So root 4 times root 13, which we want that perfect square because we can simplify that to be 2. And so 2 root 13. And you can always check to see if you did this correctly. In your calculator, if you take the root of 52, you'll get a nice, long, nasty decimal, 7.2 something, something, something. If you then take 2 times root 13, you'll get the same nasty decimal you got the first time. So if you plug in these 2 values and get the same decimal, you know that you've simplified it correctly. Okay? Anybody have one that they came across and had a little bit of trouble with? Since
Wait, what did you just say?
I said that if you want to check your answer to see if you simplified it correctly, put root 52 into your calculator and you'll get 7.2 something, 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 something. Then take 2 times root 13, put that in the calculator, and it will equal the same 7.2 something, 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 something. Okay, because these are equivalent values, because all you did was simplify. So the values are the same, even though the numbers look different. So that's a way to check. Any that you did and you are having trouble simplifying the root maybe, or setting up the equation, or solving the equation? Any others you want to talk about? Julia?
It's not a problem. Is there a trick to find the biggest?
Well, kind of. There's only a finite number of perfect squares that you're really going to be dealing with. You know, I mean, unless your number's really big, like 600, you can pretty much count on it's going to be one of these first 6. You can easily tell whether or not it's 25, right? Because 25 is very easy to count by, 25, 50, 75, 100, so on and so forth. You can easily tell if it's 9. How can you tell if 9 goes into a number just like that? What's our divisibility rule for 9? Like, how would I know that 9 goes into...
2 numbers that equal like the last number.
Well, if my number was 32,310, how would I know that 9 goes into that without doing any calculations other than simple addition? Go ahead.
They both start with 3.
Good guess.
You add them all up, and if they equal 9, then.
If they equal 9 or a multiple of 9, so if these individual digits, 3 plus 2 plus 3 plus 1 plus 0, that equals 9, therefore I know 9 goes into that number. If they were to equal any multiple of 9, such as 18, right, then I know that 18 goes, or that 9 goes in that number as well. So, I mean, it's a little bit of trial and error until you really get to know perfect squares and numbers and things like that, but there's not a whole lot of numbers to test. You can write the perfect squares on a help sheet, for sure.
Can we put the Pythagorean triples on a help sheet?
You can put the Pythagorean triples on a help sheet. I think, aren't they? Isn't it a key point?
Some
Yeah,
sort.
then yes, you can. Okay, any others of these you want me to go over?
Are we done? Should I? No, we have homework.
I am going to give you homework, so you can work on it here.
You don't give us homework?
No, I am going to give you homework. I should not need to stand up here and defend myself for giving you homework when you are students and I am the teacher. Like, this was not covered in my how to be a teacher classes. In college, they told us that students love homework, that we would get applauded when we assign homework. Well, I don't have to do it, so I don't.
Alex, guess what question?
I never scoffed at an opportunity to improve my education.
Oh,
Did you?
oh,
That's
David.
kind of-
Wait,
Wait,
Oh,
nudge,
David.
nudge.
Star students, yes.
Alex, guess what questions you're gonna give us? If you get them all correct, do we not get homework?
Yes.
Please. If you get them all correct, if you get the
Okay,
exact
just tell
questions right, then do we not get homework?
I'm gonna add.
On page 436, well, obviously, if he tells me what questions that I'm going to give him ahead of time, I'll just add one. So it's more fair if I present them first, and we'll see what he came up with. So on page 436, I would like you to do 3 through 7. Nope, sounds like we're done. Okay. 3 through 7. Then 14 through 16.
You got that right.
Well, there's some more.
Oh.
14 through 16.
Wait.
24 through 26.
7, 13 through what?
What is this?
This is your homework. Do you not get homework in other class? And
No, we do get homework.
It's not this
That's
one.
why we don't want homework in this class.
what? And 29.
Do you grade our test?
Do I what?
Hey,
Do I grade your tests?
What? Never mind.
Yes, I do grade your tests.
No.
Okay. Okay, so there you go. That is your assignment. We're off next week, so technically this assignment isn't due until 2 weeks from now. So I don't think it's all that bad. You can stay here and work on it if you'd like. Otherwise, that's a wrap. That's how you math.